We're asked to construct a single line approximation of the Bode diagram on a 5-cycle semi-log graph paper. So we're going to have something that looks kind of like this. The total magnitude and total phase plots must be on the same graph. So we're going to do both the magnitude and the phase on this graph. We need to label the graph with the vertical scale, the magnitude in dB, and phase in degrees, and horizontal scale in rads per second. So for horizontal scale, we can see I have this written out. This can also be written as like 10 to the 0th, 10 to the 1th, 10 squared, 10 cubed, and so on and so forth, but I like to write it out just seeing the actual values. And then for our magnitude, we know it needs to be in dB. So we have this blue dB like this. We go from 0 to 60, right? And then we have our degrees, and I just put 45 degrees and 90 degrees here. Now, if we look at the notes linked below the like button on approximately page 98, we have a bunch of different, we have a table with a bunch of different summary of Bode straight line magnitude and phasor plots. So we can use this to actually form our Bode diagram. So we know that whenever we have an h of s like this, we need to, since we're dealing with magnitude and phase, remember, magnitude and phase is in the j omega. So we're going to convert this to be h j omega set equal to 20, and then we have our j omega plus 200, and this is being divided by our j omega plus 4000. What we need to do from here is we need to get both sides. What we need to do from here is take our k, which is the 20 out front, multiply it by our zeros, and then divide it by our poles. And then inside of here, we need to make it look like what we have in the factor part of our table. And we'll get to that in a second. But if we have our k, which is 20 times our 0, which is 200, divided by our pole, which is 4,000, we're going to get a 1. So I'm not going to write that out, but just know that there's a 1 out front. Now, we have this up top, we have j omega plus 200, right? And then basically the same format on the bottom. Well, we can see that we need a 1 plus j omega divided by our z or our p. Now, what we're going to want to do, even though it looks a little bit different than the factor table, it still works. We're going to multiply both the top and the bottom by 1 over j omega. And so if we do this, again, we have the 1 out front, and then we're going to have a 1 plus 200 over j omega on the top, and this is raised to the n is equal to 1, and then we're going to have a 1 plus j omega, we're going to have 1 plus 4,000 over j omega, and we have our n is equal to 1 on the bottom here. And now we are going to look at the middle part, so on line 4 and line 5 of our table, we're specifically going to look at these parts. So in looking at this, what we can do first is look at the magnitude. So the magnitude for the first one, it's going to be going from our first value all the way until z. Our z here is equal to 200, and so it's going to go to 200, meaning that we're going from 0 past 100 right to 200. So we're going to be going along here. Now, after this, it's going to go up at 20 n, our n is 1, so just 20 decibels per decade. So every decade, which means the next decade is here, it's going to go up another 20, meaning that it should be around right here. And then after that, it's going to go up another 20, so it should hit 40 at about right here. Remember, this is going up at 20 decibels per decade. And after we write this out, let's look at the bottom part. So remember that our poles, so p is equal to 4,000 here. Actually, this should be a negative 200 and a 4,000. So we have z equal to negative 200, and their pole is the negative 4,000. So with our pole being the negative 4,000, it doesn't terribly matter. What we're going to have here is we need to look at the fifth part, and we can see that we're going to basically be doing the same thing just on the bottom part of our graph. So we're going to go from 0 to p. Our p is the 4,000. So we're going to go until approximately well, this 1,000, then we're going to count 2,000, 3,000, 4,000. So 4,000 is right here. So we could just dot this line, and then we're going to go to 4,000, which is right here. And then we're going to go down at 20 decibels per decade. So we're going to have basically a -10, -20. Our next decade is, I think, about right here, 20. So it's going to look like this. And so, oh, that should be a dashed line. And then it's just going to keep on going. Now, we need to write the total magnitude for this. We don't care about these separate magnitudes. So the total magnitude, we can look at the points of, I think it's called inflection, or basically where it changes. We have 1 point right here. We have 1 point right here as well. And that's it. So when we look at this, we can see that it's going to be 0 up until this point. So for the total magnitude, nothing changes before this first part. So what we can do is erase all of these little dots because they're not included in our total magnitude. After this, we're just going to go up, right? Because we need, the total magnitude is basically the top part added with the, or sorry, not the top part, but the graphs added together. All of the different magnitude graphs added together. So we have this, and it's going to just go up because we can see that it continues to be 0 for this second one right here. So the only one that we're going to care about is this right there. So we're going to go up until we hit approximately this point right here, right? Once we hit this point, I'm going to erase the 20 decibels per decade. What we need to see is that right here, we're going up at 20 dBs, right? But right here, once it hits right here, we're going to go at -20 dB. And so when we add them together, what we're going to get is a 0, meaning a flat line, meaning that we're going to have to erase all of this and combine it with our previous graph. And so from here, we're just going to have a straight line. And it's going to look something like this. So that's what our magnitude graph is going to look like. And this could be a little bit straighter, but this is basically a very rough sketch of our magnitude graph. Now we can look at the phase. And for the phase, we're going to be looking at the same table. We're looking at the same factors. For phase though, our z is equal to 200. We're going to go from the z divided by 10, which is 20, till we hit our 200, and then we're going to go to 2000. So the first z is going from 0 to 20, which is going to be like right here. I'm also doing it above the blue line. It should be on the exactly on the blue line, but I don't want to like mess it up when I erase it. That's the only reason why I'm not doing it right there for now. And then it's going to continue. It's going to go from here, and then it's going to go through our 200, and then up to our 2000 at an angle of 45 degrees. So let's find 2000. It'll be like right here, right? So we can draw this in. It's going to be 2000. But since we're going up at 45 degrees, it's going to go until we hit this 90 degrees here. So 2000, we have 90 degrees, right? And at 20, we should have it at 0 degrees. So we can draw this line, and then we can draw this line. So this is 0 degrees, this is 45 degrees, and then this is 90 degrees. Now we need to do the same thing for our pole. So our pole is 4000, or it should be negative. These are both negative, but again, it doesn't terribly matter here. It kind of does if you were to plug it into a calculator, but as long as you know what you're doing, negatives are just kind of directions. So from here, our p, we know we need to divide it by 10. We're going to get a 400. We're going to go through 4,000, and then we're going to go through 40,000. And we're going in the negative direction. So we know 40,000 is past this 10,000. We have 20, 30, 40,000 right here. And then just because this graph is smaller, we'll just do 45 degrees and 90 degrees here. But we don't need to write this because, well, we'll see why in a second. And then let's see, we're going to 400. So we have this 100 here. We have 200, 300, and 400 is right here. So 400 being right there, we're just going to write it right here. Meaning that for this graph, we're going to go from 0 to 400. This is 0 degrees. Then we're going to go over here, 45 degrees, and then pass this at 90 degrees. This is all negative. So this is negative 90, this is negative 45. Now we need to add everything together. So we're going to look at the inflection points. That is like right here. We have a change right here. Then we have a change right here. And then a change right here. So we have 4 parts that are going to be changing in our graph. That's really important to note. So now we can start drawing it. What we can see is that up into this spot, we're just going to be at 0 degrees. So we're just going to look exactly like this, 0 degrees. Now, until we hit here, we're only going up by 45 degrees because this is still 0, right? And then this is going to give us a degree of about 60. So it's going to go until like right here, right? So that means we could take our eraser and erase everything after this, as long as we note that basically what we have is 60 degrees. So it's going to stop right here, right? This is the 60 degrees. So we can erase this, and we're just going to copy this until we go right here. And then we can erase this part right here. Take that out, and we're going to also take this part out as well. And so we can take that as well. And now we can look and see that, well, this was still going up at a 45 degree angle, and we have this positive 45 minus this 45, or plus this negative 45. And so that is going to make it a straight line, and it's going to be a straight line until we get to here. We'll see why in a second. So it's going to be straight line just like this. And now after this, we're going to start going down because this flattens out, right? But after here, still through here, it's going to be going at a negative 45. So we have to have a negative 45 degree angle. And so until it reaches right here on our graph, we're going to go down to it. So it's going to come down like this, and then afterward it's just going to continue on. And so now we can clean up our Bode plot by just erasing all of this extra stuff that we use to find the magnitude, and it's going to look just like that. So, and remember, this kind of tops out around 60 degrees. And that is how you'd go about kind of looking at the magnitude and phase for this kind of problem.